Hello everyone, let's start the given question. The question says that an LPG, that is liquefied petroleum gas cylinder, weighs 14.8 kg when empty. When it is full, it weighs 29 kg and shows a pressure of 2.5 atm. In the course of use at 27 degrees Celsius, the weight of the full cylinder reduces to 23.2 kg. Find out the volume of the gas in cubic meter used up at the normal usage conditions and the final pressure inside the cylinder. Assume LPG to be N-butane with normal boiling point of 0 degree Celsius. So in this question, what we are going to do is firstly find out the weight of butane gas in the cylinder, right? So what is the weight of butane? So weight of butane will be equal to 29 kg minus 14.8. So the value here will come out to be 0.2, that is 4.2 grams. So this is weight of butane. Now we need to find out, since it is given that the weight of full cylinder reduces to 23.2 kg. So if the weight of cylinder also reduces, now what will be the weight of butane gas? So weight of butane remaining here it will be equal to 23.2 minus 14.8. So this value is coming out equal to be how much? It is coming out equal to be 8.4 kg. Now we are going to use the equation where we know that P1 divided by P2 is equal to N1 divided by N2. So from this we'll be able to find out the value of pressure. So the value of pressure P2 will be equal to what from this? It will be equal to N2 divided by N1 into P1. So it is coming out to be equal to 8.4 divided by 14.2 and multiply with the pressure value, which is equal to be 2.5. So what we are going to get here, we are going to get the value of the pressure, which is coming out to be how much? Upon solving this, we are getting here equal to 1.48. So upon solving this, we are getting this value. Now we know that pressure of gas outside the cylinder is how much? Pressure of gas outside the cylinder is equal to 1 atm, right? And we also know PV is equal to what? PV is equal to nRT. So what is the volume of the gas? Volume of the gas is nRT divided by P, which will become equal to, so this value will become 14.2 minus 8.4, multiplying this value into 10 raised to the power 3. You have to divide this value with the 58 with gas constant 0.082 into 30. Divide this whole value by 1. Solve this value, you are going to get the value of volume. So volume will be equal to 2460 liters. And we are going to calculate this value in meter cube, because in the question we have been asked to calculate the value in meter cube. So in meter cube the value is coming out to be how much? The value is coming out to be 2.46 meter cube, right? So this is the volume of the gas, that is 2.46 meter cube. So this is your answer to the question. Thank you.
Hello students, in this question we have 4:1 molar mixture of helium and CH4 which is contained in a vessel at 20 bar of pressure, and when we did a hole in a vessel the gas mixture leaks out. Basically this is a effusion process. Okay, so this is a effusion process. So we need to find out that what is the composition of the mixture effusing out initially. So in this we are talking about effusion, so we can apply Graham's law of effusion, right? We can apply Graham's law of effusion. And according to Graham's law of diffusion, we have one formula: R1 upon R2 is equal to P1 upon P2 under root of M2 by M1, where R is the rate. Rate can be anything, like it can be concentration per unit time, it can be volume per unit time, it can be moles per unit time, and we will use here rate as moles per unit time, right? And P1 and P2 are the partial pressures and M2 and M1 are molar mass, right? So in this question we have molar mass of helium and CH4. We need to calculate this rate, because from that rate we can get the number of moles of composition of the mixture effusing out, right? And we have to know that what is P1 and P2, that how to calculate this P1 and P2. So we can use Dalton's law of partial pressure for calculating P1 and P2, which is partial pressure. So what is Dalton's law of partial pressure? Let me tell you a little bit about Dalton's law of partial pressure. It is a gas law which states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressure exerted by each individual gas in the mixture. For example, we have three gases, so their P total means their total pressure is equal to P1 plus P2 plus P3, and P1, P2, P3 are partial pressure of gas 1, 2 and 3. Okay, and in the another form we can write down as partial pressure of 1 as mole fraction of 1 into P total. Let me write down like this. It's only P total, right? And for similarly for P2 we can write down mole fraction of 2 into Pt, right? And P3 also mole fraction of 3 into P total. And what is mole fraction? Mole fraction is the ratio of that component's mole upon total mole. Okay, so now what we do, we will use this formula to calculate the partial pressure. So we have helium and CH4 in the molar ratio of 4:1. So suppose that total moles are 5x, then helium should be 4x and CH4 should be x moles, right? So how to calculate mole fraction of helium? This becomes 4x, which is the moles of helium, upon total moles, which is 5x, and for CH4 this is x upon 5x, right? Now applying this formula, because we know everything now, we know the total pressure and we know this mole fraction. So by applying this formula, what we get? Partial pressure of helium is equal to 4 by 5 into 20, which is equal to 16 bar. Okay, and similarly partial pressure of CH4 is equal to 1 by 5 into 20, which is equal to 4 bar, right? So now what we do, again putting all the values in this formula, okay? So after putting all the values, we will see that R of helium upon R of CH4 is equal to, which is basically rate of helium upon rate of CH4, is equal to partial pressure of helium upon partial pressure of CH4, right? And under root of molar mass of CH4 upon atomic mass of helium, right? And this should be equal to how much? 16 by 4 into 16 by 4. So this get cancelled, and root 4 is 2, so 4 into 2 is equal to 8. So the ratio R helium to R CH4 is equal to 8:1, right? And we can also write that this R helium as moles of helium upon time, because both gas are diffusing at the same time. So this become NCH4 by time. So this is 8/1. So from here we can get N helium is to NCH4 is equal to 8:1, which is our which is our required relation. So answer of this question is 8:1. Thank you.